In this video, we'll look at how to handle collisions between physical objects using the physics engine in Corona SDK. Physics engine collision events are exposed through the standard Corona event listener model with three event types: collision, pre-collision, and post-collision. For general collision detection, you should listen for an event named collision. The collision event includes phases for began and ended, which signify the moment of initial contact and broken contact. If you don't implement a collision listener, this event won't fire. Pre-collision is an event type that fires right before the objects start to interact. Depending on your game logic, you may wish to detect this event and conditionally override the collision. If you don't implement a pre-collision listener, this event won't fire. Post-collision is an event type that fires right after the objects have interacted. This is the only event in which the collision force is reported. See the Collision Forces section in the documentation located on the Corona Labs website for more details. If you don't implement a post-collision listener, this event won't fire. Collision events in Corona have a propagation model similar to touch events. You can use this to further optimize your game performance by limiting the number of events that are created. By default, a collision between two objects will fire a local event for the first object, then a local event for the second object, then a global event for the runtime object, assuming all have active listeners enabled. However, you may only be interested in some of this information. Any collision event handler that returns true will stop further propagation of that collision event, even if there are further listeners that would otherwise have received it. This allows you to further limit the number of events that are created and passed to Lua. While individual events are not very expensive, large numbers of them can affect overall performance, so limiting event propagation is a good practice. Collisions are reported between pairs of objects and can be detected either globally using a runtime listener or locally within an object using a table listener. In this example, we'll detect a collision when a crate falls to the ground. Both the crate and the ground have been given text values using a .myname association. We've also created an onCollision function that prints out the names of the objects involved in the began phase and ended phase of the collision. This function is assigned to the global event listener that listens for collision events. When the crate collides with the ground, the global event listener calls the onCollision function, which accepts the event object and prints messages to the terminal window based on the phases of the event. And that's a look at how to handle collisions between physical objects using the physics engine in Corona SDK. Learn more about working with Corona SDK at coronalabs.com/university.